Morning, everybody. Welcome to SOS Webinar. My name is Mirjana, and I will be your admin for today. Webinar is focused on IKF and their new module, DCTR 72. Webinar will be led by Šimon Chudoba from IKF. At the beginning, I would like to say some information regarding the webinar. So, first of all, if you will have any question regarding the topic, please address your question to Q&A window, and your question will be answered during the webinar. Also, if you have any question regarding WebEx and functionality of WebEx, or something is wrong, please contact me via chat. Also, I would like to tell you about the special offer which will be offered to all of attendees to webinar, and you can use a special price for DE Start 3 with the new modules, or you can even buy a single module for special prices. All these offer will be sent tomorrow after webinar to you, and you can use this opportunity if you would like to. One more thing is this webinar will be recorded, and you can find the whole presentation of this webinar at our webpage next week. So now I would like to pass the word to Šimon to start his presentation. Good morning, Šimon. Can we hear each other?
Hello, good morning. This is Simon.
Okay, so I will switch role to you, and you can start your presentation, please.
Okay. Good morning, everybody. Welcome to this webinar. This webinar, as it was said, is focused on the data control transceivers, the new generation from the IKF, which is the 7th series. So I hope that you can see my presentation right now. If you don't, Miriam, please stop me. So
it's visible, so thank you.
It's visible. Okay, perfect. So let's start with this directly. Basically, this webinar is focused on the new generation of the modules, and it's, let's say, a little bit advanced webinar. So we will not cover the basic things. So this webinar is rather for those who have some kind of experience with the IKF modules and the IKF technology. So if this is, let's say, too advanced to you, you can come back to the previous SOS webinars or to our let's say technical videos where you can get the understanding of the basics. So as it was said, it's completely focused on the 7th series of the modules. That's one thing. And the second thing is that it's focused on the data control transceiver. So this is something what we see as the future of the IKF. So basically the combination of the new modules and also the focus on the data control transceivers, because data control transceivers make the development much easier, enable the interoperability between different types of products from different companies. So this is the goal. This is, let's say, the path that the IKF will go. Just to give you a little bit understanding, like what's the difference between transceivers and data control transceivers. If we take a look on the MCU, on the TR, there was a operating system from IKF, and then you had to write your whole application. This means there was quite a lot of coding. You need to have your experience and also programming skills. And the other thing is that then you were not able to use your products with products from another manufacturer. So those are the reasons why we came with the data control transceivers. And part of the application, let's say, space on the MCU, we use for what is called hardware profile. So this is a plugin that you very easily upload to the modules, and then you don't have to take care how the message is delivered through the network. what should happen if you receive a packet, and so on and so on. So there are a lot of features that are already implemented in the hardware profile, and you don't have to deal with this yourself. This means your development is much faster, your products can be interoperable with the whole IKF ecosystem, and much more. Nevertheless, even though we provided the hardware profile, there is still enough flexibility for you to, let's say, modify the functionality of the module, especially for your device. And this is done by this custom handler. So the custom handler is part of the code in C language. It's based on the events. So basically the hardware profile is running in the loop with certain events, and in the specific event, you can take over the control, do whatever you need to do, and give the control back to the hardware profile. So you have the flexibility, but you can develop much faster. So that's the main difference between transceivers and data control transceivers. Here is a little bit reminder of the structure of the packet. So basically, you control the whole communication with few bytes. The first byte is network address, so you just say, I want to communicate to the node number 5, let's say. The second byte, or 2 bytes actually, define what's the hardware profile ID. This means that every manufacturer has a different ID, which is provided by the IKF Alliance. And with this, you can differentiate products from different manufacturers, even though they are using, let's say, the same peripheral. Let's say SPI is used by one manufacturer and the second manufacturer, but you can differentiate the communication to the right devices with this hardware profile ID. The third byte, let's say, is a peripheral number. So this decides which peripheral on the specific module you communicate to. So you can, the module, let's say on the module, you can communicate to the temperature sensor, you can communicate to the SPI, you can communicate to the UART. So this is what you define by the peripheral number. And then each peripheral has specific commands. So basically for the temperature sensor, it could be read the temperature. For the LED, it could be switch on LED or switch off LED, and so on. Again, those are predefined commands, and then you can add your data, up to 56 bytes of data. So this is the structure of the packet that you can use. You see, it's very easy. They are predefined peripherals, and also you can create your own peripherals with a custom handler. So what are, let's say, the key things or key things regarding the new series of the module? First of all, we keep the architecture of the D modules. This means for you that if you have your applications written for, or let's say hardware profiles, and your custom handler written for 50 series, so we call them like blue modules, and here those are the red modules, the 7 series. So if you have your application written for the blue modules, you can use them from, let's say, 95% also for the red modules. There are just some commands, let's say, that should be slightly modified, but this is something we can help you with. The second thing is that there is a same pinout. So basically, if you have your hardware ready, you don't have to change anything. Another difference is that now the MCU is running on 16 megahertz, so we increase the speed. And also on the red modules, we are using Spirit 1 from ST, which is like, let's say, 2-generation new modules comparing what was on the blue modules, and we are using also a different modulation. Now it's GMSK. Also, we dramatically increase the external EEPROM. On the blue modules, you had 2 kilobytes. Now you have 32 kilobytes. So big increase. Also, a new thing is the 10 shielding. So what you can see here on this picture, This is especially important for those who want to export to countries where FCC applies, like US or Canada and other countries. So you will have no troubles during certification of your product. So all the modules will be pre-certified for ETSI as well as FCC. And GMSK modulation, there are a lot of benefits of this modulation. One of this is definitely the much better selectivity. So far we were saying you cannot use in one environment, let's say, channel number 10 and channel number 11 because there would be collisions. But with these new modules, you can use every single channel, really, like channel 10 and channel 11, and the modules will not interfere at all. One, let's say, consequence of using a different modulation is this, that the red modules cannot communicate in one network with the blue modules. So blue modules and red modules cannot work in one network, basically. But anyway, there's a very easy migration from the blue modules and red modules. So it should be very easy for you to get on the red modules on the much modern communication. Here, some key points from the consumption perspective. What I would highlight here is on the low power mode. For those who remember it, the low power mode on blue modules was somewhere around 330 microamps. So here with the red modules, we are on, let's say, half of it, pretty much. And another important thing is during the maximum power when you transmit, we are here on 17.6 milliamps, whereas on the blue modules, we were on 21 milliamps. So also you will save quite a lot of energy on the transmitting and on using the module. And also, even though the consumption is much lower, the range, let's say, doubled. You know, so now with the red modules on the open air line of sight, we have definitely over 500 meters. On the blue modules, it was, let's say, 300. On the red modules, it's 500, 600. It depends on the condition. Even one of our distributor did his measurement, and he measured like 2 kilometers. But those were very special conditions. He put one of the module like 20 meters high on the pole, and then he measured 2 kilometers. So this is definitely not a standard application. But generally speaking, you can expect something around double range than for blue modules. Also, we increased a little bit the speed of communication, but it's just a minor increase. The first versions that are available are 72 and 76. For those who are experienced with IKF, you can easily differentiate those. The 72 is ready for a SIM card holder, so you can use it in your device where you want to easily plug in the IKF module, and the 76 is ready for soldering. So those are the same pinouts as we had for 52 and 56. Regarding the availability, so now we have the 72 DA, DAT especially. So with antenna and temperature sensor, those modules are available as a samples. Even those modules are for free for a limited amount. So if you want to test it, you can order, let's say, 3-4 pieces for your tests right now. Regarding the production, we plan 72 to be fully released at the end of July, and the 76, let's say, at the end of August. So this summer, you can expect the full release of 70 series modules and everything which is related to this, which we will discuss shortly. So new products that are coming with the red modules. So those are 72D and 76D, as we discussed. This is also coming with a new development set. BS Start 04 will be equipped with the 72D modules. And as you know, DSDPA consists of 2 boxes of DS Start, so basically there will be DS Start, DSDPA 02. We are working on the USB gateway with the red modules, as well as the Ethernet, DSM, and Wi-Fi gateways. You can see that the name of the gateways will be the same, and you will just specify which module you want inside with this prefix. Then we are preparing also a router on 72D modules. So this will work basically on the hardware profiles. So this means you can just plug it in and basically you have your router ready, and there's zero development. And also the IKF Cloud, which is going to be released during the summer, will be supporting the 70 series modules. So those are the products that are coming this summer. And what are the innovation and improvements comparing to that we've done, let's say, in the last year, and that we are preparing over this year and next year? So first of all, there is a new operating system which is coming. It's 3.07. Again, everything of this will be released this summer. There's a new DPA or hardware profiles coming, 2.20. Also, a new IKF IDE for the 23, and a new IKF Cloud, which will be available again, like in the summer. By the way, for those who don't have experience with doitwireless.com, I would recommend to go there. You can find a lot of, let's say, inspiration for your development. This is a, let's say, open forum for you guys who want to discuss your development. And also, we share some ideas how you can work with the IKF Rep. So do not hesitate, go there and see what if you find anything interesting for you for your development. So basically, IKF is becoming really a complete ecosystem ready for the development, but also new products, new interoperable products are coming into the IKF ecosystem. So this is really like a big environment that you can use for your projects. So as you can see, it's becoming pretty complex, but basically you have interoperable products that are connected through the IKF wireless mesh networks. Those devices can be from different manufacturers, and thanks to hardware profiles and the DPA protocol, they can operate in one network, so they're basically interoperable. Then you can control the whole network with the gateways from microwave, let's say Wi-Fi, Ethernet, or DSM gateway, or the USB gateway connected to your computer. Or what you can do is to create your own control device, let's say based on Raspberry Pi, Arduino, or whatever. Basically, whatever kind of device that supports Java or C programming. We will discuss it more in detail. And then you can have a internet connectivity. This can go to the IKF Cloud, which is accessible through the, let's say, API, or also on the web interface. Or also, you can license the whole solution and put it on your server. So then you have your data completely under control, and they don't go to any third-party server. Also, from your Java devices, you can get directly to the internet and to your control software, or even what we provide is a library that makes your device, let's say this Raspberry Pi control unit, connected to the IKF Cloud. So basically, it opens a lot of possibilities how you can build up your project. But definitely, you don't have to develop everything from scratch. Our goal is to make your development as fast as possible and as easy as possible. So it's the situation is really coming right now where your project will be rather putting different bricks together and build up the whole wall, rather than to start from scratch with the development and with the integration of the IKF modules. So what are new and planned features? So first of all, very important and something what we heard before about increase of the range. So as I said, the range was pretty much double. Also, the red modules support a low power mode. A new feature, what you perhaps haven't heard about, is the Selective FRC. For those who are not experienced with FRC, it stands for Fast Response Command, and this is a feature, or this is a command that collects data from all the nodes in your network. So if I give example, if you need to collect the temperature from 30 nodes, with standard polling, you would have to communicate to node number 2, node number 1, 2, 3, 4, and so on separately. So then actually the time that you need for this communication grows exponentially, and it takes a lot of time to download even very small amounts of data. So this is why we developed this fast response command, and basically the fast response command works in the way that it sends a broadcast query, and then the packet is coming back, and each module adds his information into the right space or right point in the packet when it's coming back. So basically, with this, in one communication there and back, you can collect 1 byte from up to 60 nodes. So what we are coming. So this was the original FRC, and since we observed that this is really very popular, very effective for your project, we brought new features for the FRC. So one of them is a Selective FRC. So far, you sent FRC and it was collected from the first 60 nodes, from node number 1 to node number 60. But now, with the Selective FRC, you can choose from which modules you want to collect the data. So basically, you can say, I want data from node number 5, 13, 220, 221, and so on. Okay, so basically, you can select up to 60 nodes that you can collect the data from. Another thing is that quite often, let's say the temperature sensors, they provide not just 1 byte but 2 byte data. So in order to make it more effective, we created 2 byte FRC. So then it's limited only to, let's say, 30 nodes, but this could be combined with the Selective FRC. So you can say, I want 2 bytes from these and these nodes. I'd say the last or another new type of FRC is acknowledge broadcast. So far, when you send a broadcast command, let's say to switch on all lights, you didn't get a feedback, and that's why we created actually a special FRC, which we call acknowledge broadcast. And this means that you send a command, or like switch on lights, and you get a confirmation. So you get a confirmation this and this and this light were switched on. By the way, this acknowledge broadcast doesn't serve only for let's say confirmation of some action, but it could be used also for collecting data. So this is something which I will show you later on. But basically, you can send a message like switch on the lights and give me data of the temperature band. Okay, and also you can combine with the Selective FRC. So you say these this and this lamp will switch on and give me data from the temperature. So you can combine the different types of commands and data collection, and everything is just in one communication. So it's very, very, very effective. Another very important feature which is coming is peer-to-peer packets or peer-to-peer communication. So far, the DPA was focused mainly on, let's say, mesh networking or controlling the mesh from the control unit. The peer-to-peer packets enable to communicate from one node to the others, so basically to all the neighbors. This could be used, for example, on the, let's say, street lighting. All right, you come to the or traffic lights. You come to the crossing, and you want to push the button and switch on the lights, for example. So this is what could be done with peer-to-peer packets. Or you need to, let's say, control your indoor lights with a switcher. So again, you can come, you can push the button, and very easily you can get the communication directly to the nodes that are in the direct range. Another feature is what is called module cloning. So this is coming. This will be released this summer as well. So basically, this is important for, let's say, safety of your installation. So just imagine the situation that you have again, like a, let's say, street lighting application, and your control unit will burn out. In order to have a very easy fix, you need to come with a module which is basically a clone or the complete copy of the original module. So so far, the only option was to order the clone from MicroRisk directly. But now you will be able to do the change of the MID, the module ID, yourself. So the last thing is what we call as the alternative DSM called CAT. So basically, CAT is a servicing tool which enables you to get connected from your device or from your, let's say, application or from the IDE to any module which is even installed and part of the network. So basically, you can come to when I'm using still the example of the street lighting. So you can come to the light, and you can get, there's something wrong with the communication on the light, and you can get connected from your laptop directly to the line. And you can then upload a new firmware, you can upload even your operating system, and you can do a lot of, let's say, servicing things. Previously, we had the dedicated channel of the channel number 0 was dedicated to this communication, but then we had an experience on an exhibition where the channel number 0 was completely jammed, and we were not able to communicate to the modules through this channel number 0. So then, based on this experience, we enabled that the channel could be defined. So basically, you can then say, okay, now we will switch to channel number 13, which is completely empty, and we can do the servicing on this channel. So here, this red, let's say, red features I will show in the second part of this webinar in practice. So basically, I will show really how to work with the Selective FRC, how to do the acknowledged broadcast, and so on. Another thing which we are coming with is automated build-up of the network, which is very important for your easy deployment. So basically, you just put your devices on their final place, you start on the network, and the network will build up itself. This is, again, something that I will show you later on today. OS upgrade, that's something which will help you, especially with development. Because so far, when we came with a new operating system version, The trouble was that you had to take your modules and send them to us, and we would upgrade the operating system and send it back to you, which is like extra logistics cost and so on, and time loss and so on and so on. So basically, from if you have modules with the operating system 3.06, you will be able to upgrade them to 3.07 yourself very easily. So all the logistics costs are done. By the way, you will be able also to do it wirelessly and do it through the servicing tool. EN 5425 conformity. I'm not sure that you are aware of this norm, but basically this norm is valid for smoke detectors, fire detectors, and these kind of devices that influence or that have to secure the lives of people. This is extremely strict norm, but brings a lot of opportunities on the other side. So basically, we are now very close to get this certification, which will open or which will, let's say, help you to create these fire detectors, smoke detectors, and so on very easily. We will also work on a special hardware profiles or special application that will come with the modules. So the norm is completely fulfilled. So basically, then you will just get a module, plug it into the smoke detector, and it will work in the way it's supposed to, based on this norm. As far as I know, we should be one of the first technologies, especially working in the mesh, that will support this norm. So this brings all of you a big benefit and opportunity to hit this market. Something which we are very often asked for is the encryption. So the encryption is something which is coming. It's supported with the Spirit One, with the RF chip, which is on the module. As far as I know, the encryption is coming, let's say, next year. So this is on our, let's say, long-term roadmap. And also another thing is a channel assessment. So basically, so far as you know, you can use just one selected channel, but our goal is to use more channels and even to change channels automatically based on the say density of the communication on the particle channel. So again, this should make the communication much more robust, and especially currently the air is not really, let's say, jammed with the different type of wireless technologies, but this time is coming. So at 868 as well as 915 megahertz bands will be pretty jammed soon. So we will be ready for it. We are working on that already now, even though it's not a problem in the most of the environment. Auto network, as I said, something which I will show you very soon. Also, what we want to work on are the communities, because there are a lot of, let's say, people, manufacturers, integrators, hobbies that are using different types of ready devices like Arduino or Raspberry Pi or different types of MCUs. So we want to help you to integrate IKF in those kind of devices very easily. So basically, first of all, we provide libraries as well as hardware tools to create a device with the DCTR, and also to create a control unit based on the DCTR. So this should then, because there will be two versions, or the library is in Java and C language. So for the libraries in C, those could be used for this kind of chips, and for, let's say, Java and C++, you can use it in PC, Plug PC, Raspberry, and those kind of devices. And for the hobbies, it's especially Arduino, ChipKit, Raspberry. So again, you can see a hardware shield here that you can then easily plug in the IKF module, and you will have a lot of libraries with the ready commands that you can use directly. Again, it's built based on DPA protocol and the hardware profiles. So you can expect more and more devices available even with the integrated IKF. So regarding the pricing, I think this is something very important as well, and something that you might be interested in. So basically, frankly speaking, our production cost of 70, so the red modules, or 70 series is higher than the 50 modules. But on the other side, we believe that 70 modules are the future of the IKF, and we want to promote them. So basically, we decided that the price of 70 series will be lower than the 50 series. So you have also an economical, let's say, reason to switch from 50 to 70. So here is a short comparison. On 100 pieces, you see that on 52 DAT, it would be on 15.63 euro. Whereas on 72 DAT, you would be on 14 euro. So even on 100 pieces, you save like 163 euro. And if we go to 1,000 pieces, you can see the difference on your screen. And here it makes 1,000 pieces even over 1,000 euro. So this is another reason why you might think of migrating from the 50 modules to the 70 series. Another thing is that we will support, as we said, the DCTR. So basically, the TR modules will not be available up to 100 pieces. So if you want to have your, let's say, project based on TR modules, you can, and you can order 100 pieces plus. If you want samples and if you want to just like, let's say, develop something, you would need to use the DCTR, and then you can compare all functionality from DCTR and TR. So basically, that's the logic. Those, by the way, yeah. Here is the let's say area where we will not provide the TR modules. Especially this is because of the logistics. So we can optimize the logistics with our distributors. By the way, the IKF Alliance members, when we are talking about the prices, the IKF Alliance members have special price. The special price is basically equal to the standard price of the TR modules. So here you can see the difference if you are not a member. So those are these prices, and if you are a member, then you have €2 less on the modules. And if it's like 1K plus, the difference is €1. So then even because the membership costs around €1,000 and or exactly €1,000, and you get much more benefit. So even without all the other benefits, if you order more than 500 pieces, then basically your membership is paid off. So if you start, let's say, ordering these kind of amounts, don't hesitate to join the alliance, because it brings you a lot of benefits like promotion and so on. It's something which we'll discuss right now. But also it comes or brings immediate cost savings for you. So now going more, let's say, business oriented. So what is the IKF Alliance about? First of all, it's about the community of the people, or let's say summarize. It's about the community of the people, or of the companies, that they can cooperate, that they can let's say buy products from the others to use them in their projects, and it's also about the interoperability of the product. So basically, the alliance helps you to make your product interoperable, so you can also provide them to the other members and to the end customers, so they can use different products from different manufacturers in one project. So this makes the, let's say, the community much stronger, and the IKF technology much more spread out. The IKF Alliance helps also with the promotion. So basically, once you are a member, we will help to promote your products on the market, especially on the markets where you have no access to, and also in certain cases, if you are interested for this, we provide we call it as extra sales support, and we are now hiring the sales partners in different countries that should help you to promote and to sell your products into different markets, or especially abroad on the markets that you cannot reach with your own sales force. So this is something which we can discuss later on in the, let's say, one-on-one communication. So regarding the community, last week we had the first IKF Alliance meeting. There were more than 40 people. So currently there are around 26 members now. Other companies are joining. So far, let's say half of the companies are from Central Europe, Czech, Slovakia, Hungary, Slovenia. But we have also companies from Finland, from France, Germany, and so on. So I would say the IKF Alliance meeting was a big success, and the company started really to closely cooperate. So if you plan to have products based on the 17 series modules and based on the DPA, definitely think about joining the alliance, because it opens a door for much faster development and much more effective promotion and sales. Here are some examples of the devices that are within the IKF Alliance that are interoperable. So you can see here, for example, a system for controlling indoor industrial lamps. So this is let's say the control. This is the node. This is the control unit. So basically, you just say this and this area is covered with this button, and you can select the specific lamp that goes into this area. So it's very effective. The company saves a lot of money on lighting on that. And there are different types of products. Everything will be displayed very soon on the new IKF Alliance website. So this is just the first print screen. This is something that you can expect in July. So this is when we will launch the new IKF Alliance website, and where, let's say, with the list of products with the case study. So this should give you much more better understanding what the IKF Alliance is about. But what we provide to the members is also communication about their applications through our newsletters. We also work with like electronic work with this portal to communicate information about the application of the members, and also we shoot different types of videos regarding the application and product that we then promote to the world, let's say. So just to conclude this, let's say, business part, if you would use the TR modules, our experience is that the development of the code, the programming, and so on would take you something around half a year, because you have to learn it, you have to get experience, study, use our examples, and so on. With the DCTR modules, I've seen many situations where the whole development was done in 8, 10, 12 weeks. Even I have a project where the whole application for the street lighting, controlling the lights, the coordinator, the control unit, they developed everything in 12 months and put it on place. So it's very, very fast development. If you use not only data control transceivers, but also the ready gateways and the cloud, then the development could be matter really of few weeks. We had a let's say, case study here where the company developed a CO2 sensor, and because they use a ready gateways and they use a ready cloud, which was just slightly modified for their application, they had it ready basically in 2-3 weeks, and in 5 or 6 weeks they went with a new wireless device to the exhibition. So the development could be really very, very fast. And then another option is actually to buy a product from the IKF Alliance. So basically, if you have a project where you need a special sensor or a special actuator or whatever, and it doesn't make sense to develop it, you can just go to the IKF Alliance website and let's say, order or get an understanding what kind of products are available, and order them from the manufacturer. So this will make your development much more faster, which means also the faster income for you. So this is why we are doing all of this, to make your development easy, fast, so you have your money in your pocket much sooner than if you go through the whole development process. So basically, this was the first part. It was just a brief, let's say, heads up of what's coming. Do you have any questions? I will now go back to the WebEx. So
yes, yes, we have 2 questions. So first question is, what is the use frequency?
Sorry, I need to go to the WebEx. Because I didn't understand precisely.
What is the use frequency? It was as the question was written at the beginning.
Okay, so the frequencies we are using especially 868 and 916 megahertz, so sub gigahertz. Also, the 50 series modules work on 433 megahertz, and on the 70 series, so the red modules, we will also open a new bands, but this is not, let's say, fixed. So far, the red modules 868 and 916 megahertz.
Okay, the next question is, how good is Selective FRC in regards on different temperatures? Meaning, is it working if one device is at 0 degrees and the rest are at +20, +40, +60, and so on?
So basically, it depends on the, if I understand the question well. First of all, you can use different type of temperature sensors. So it could be like an external temperature sensor, like a Dallas or something, or it could be a temperature sensor which is on the module. And some of the temperature sensors provide, let's say, 1 byte information. Some of them provide 2 bytes. Yeah? So if let's say they provide 2 bytes, you have, I don't know, 10 lights in your network and 10 temperature sensors. Then you can send Selective FRC only to the temperature sensor, and you can get a 2 byte information from all the temperature sensor in one communication. So basically, if there are 20 nodes, you would have, like, in 2 seconds, you will have the information of the temperature of all the temperature sensors. We will show this in a few minutes in practical demonstration, so maybe it will be more clear.
Okay, so some more questions. What I am interested PCB response on regard of temperature.
PCB response. I didn't understand. Where can I go to see the questions?
When you get on the main page, you can see it in Q&A window.
Yeah, but I don't know how to get there. I don't know.
So you can please stop sharing your desktop.
Okay.
And then you can go to the main window if you can see.
All right. Yeah. Now I'm here.
So the whole one question.
Okay, so yeah, I see here how good is Selective FRC. So yeah, The selective FRC, it doesn't matter what kind of temperature you are collecting. Okay, so basically you get 2 bytes for node number 1, 2 bytes for node number 5. It doesn't matter. So basically one node can be in -20 and the second one can be in +60, and you will just get the data. There is no difference. So how security, integrity, privacy is ensured in communication protocol, please? So basically, the protocol itself, let's say, secure the data. So you cannot read it if you are not part of the network. You cannot read it from outside, and vice versa. If you are not a member of the network, you cannot send data into the network. So this, let's say, security process is done during bonding. So during the bonding, the coordinator communicates to the node. They exchange some information and some security information. So basically, then the node will listen only to the coordinator, and so nobody else can read the communication. And basically, the security is done based on the MID, or the ID of the network is based on the module ID of the coordinator. So that's why when you want to replace the coordinator without new bonding, you need to clone the coordinator. And as I said, we are coming with the AES next year.
Okay, thank you. So after this question, you can see the other one, the one I read before. What I'm interested in, PCB response on regard of temperature.
PCB response, like in the matter of time, or I don't really understand this question. Maybe.
Mr. Mirs, may you specify your question, please, in Q&A window? So far we can switch to the next question and we get back to the previous one. So if we buy the TR module from IQRF, can we make program it for DCTR?
Actually, no. If you buy a TR module, you have a TR module. If you want a DCTR module, you need to order a DCTR module. They are, let's say, the same from the perspective of hardware, but the operating system which is uploaded there is different. So basically, you need to buy a DCTR module.
Okay, thank you. So next question is, communication is synchronized regardless of frequency change due to temperature changes? Yes. So the communication is synchronized. There's always, let's say, enough buffer or buffer of the time. So even though the modules are in the different temperature, like the communication is synchronized anyhow. So there shouldn't be an issue. Even what you can do, this is a new feature that we are coming with, is that if you have a devices, let's say, let me put it this way, during the FRC, you have 40 milliseconds to communicate from the module to your device to download the data. And if this time is much longer, then you can preset it up in the FRC. So if you have, let's say, devices that read the temperature for 10 seconds, and we really have this kind of applications, then you can set up, okay, I will send the FRC, then I will wait for 10 seconds to do the measurement, collect the data, and send the FRC back. So this is covered. Okay, thank you. So next question is, do you have 865, 867 megahertz modules which is certified from an appropriate agency? Yes, what we do, we have the modules which are we call it 868, but basically it's a
some range of the band around the 868. I don't know from heart where it starts exactly, but it's, we are talking about the same band basically. And the modules are what is called pre-certified. We have a certification from FC, which is for Europe, and for the blue modules we have the FCC certification, and this is something we will do. We will do definitely as well for the red modules. And then when you have your own product, you have to do your own certification. But the certification will be much easier because we do the pre-certification. So actually, the certification of the radio part of your device will be very easy.
Okay, and other question is, what is the temperature range the modules are working?
We support the industrial temperature range, which is -40 to +85, if I'm not mistaken.
Okay, so far there is the all questions, so I guess we can continue with the part of webinar.
Great. So thanks a lot for the questions. Please write more questions during my second part of the presentation. So what I will show you right now are a few new features that we are coming with. On the beginning, what I'm going to use is this.
Okay, Simon, may I stop you for a second? You have to start sharing your desktop again.
That's right. Sorry for that. That
Thank
will
you.
be more visible then for everybody. All right.
Okay, now it's on, so we can continue. Thank you.
All right, perfect. So what we have here, as you can see, I have 4 modules here, and I have 1 coordinator, and then I have 2 extra modules that I will use later on. So basically, the first thing that I would like to show you is automated build-up of the network. So imagine you have an application, those are lights, let's say, and you just take your 100 lights from your stock, you come to the street or to the industrial hall, you put them on the ceiling or on the poles, and you want them to be connected to this coordinator, which could be a different type of control unit like a Raspberry Pi or special PC or whatever. So how you have to do it right now is go step by step and bond separately each node to the coordinator. This, especially for the big application, could be pretty difficult process, especially when you are using, let's say, another company for the deployment, and these guys are not really electronic specialists and so on. So basically, what we are coming with is the new function, which is called auto bonding. The first, what I will do, I will read that we have no nodes bonded. I will clear all bonds, and I will show a map. By the way, I'm using here what we call as a DPA console. This is our internal development tool, but all the features that you can see here will be very soon integrated in our official integrated development environment. So only for now, for the purposes of this webinar, I will use this tool. So here you can see the map of the network. So far we have just a coordinator. And then we have here a utility which is used for building up the network. You can set up different parameters. So for example, what is the maximum pre-bonding interval? What is the TX power? You see that I have everything on very small place, so I have the smallest power available. Then you can set up basically different types of parameters. And then if you want to create the network automatically, you just hit the start. So basically this routine is available or will be available in summer in Java and in C. So basically you can integrate this functionality in any kind of software or any kind of device and so on. So now we can see that the first node was bonded and it was discovered. Okay, so now we have a network of one coordinator and one node, and in each step the network can double. So basically now the coordinator can find one node, and the first node can find another one. So now we can have like 2 new nodes. Once we have, let's say, four modules in the network, we can add another 4 modules. So this is actually how it's built up. You can see that it takes some time. So basically, my colleague that they are using the networks of, let's say, 240 nodes, it takes around, let's say, 40-50 minutes to build up, right? But it's much better than to pushing a button. So now we have it ready, and as you can see, basically we have the network up and running, okay, without pushing any button, nothing. The important thing is here that you don't know which module is which one, okay? So when you do, let's say, the installation, now you don't know where the module number 1 is located, when the node number 2 is located. So for your installation, you have to add a process how to find out which number is which hardware, okay? So this is the first part. So we created the automated bonding. You can use this for 239 nodes. It's working like very well. We have it tested, and we are just finalizing all the documentation, and this will be released in summer. So this is a great feature that will help a lot, especially with the installation on in the real environment. So now I will do the enumeration, and now I would like to show you the new let's say features of the FRC. So the first, I have here a predefined command. This is a command to read the temperature. So now what I will do, I will just read temperature. This is this command from all of the devices. Okay, as you can see here, this is the temperature in my room. 1C is like 28 degrees, 1B is 27, if I'm not wrong. So basically, I read the temperature from 4 modules at once. It was just one communication there, and I got a message with temperature from each byte. Okay. Now, let's say I want to read the temperature only from the nodes, let's say number 3 and 4. Okay. So as you can see here, I should get a message. I should get the data of 1C and 1B. I ticked also the module number 6, but it's not in the network, so I will not get the data back. So if I send Selective FRC, you will see that I got just 2 data. Okay, I got 1C and 1B, and it's always the first byte is used for something else, but here you get it in the order as you assign it. So basically, even if you put, let's say, number 70 here, and it will be valid, it will be right on the beginning. So they just go one after the other, you know. So this is a Selective FRC, very strong feature. And now I will show you how you can use it in the combination with some command. So we will use this predefined command 81. And this predefined command says that, yes, give me a temperature, but also performs this and this command. And in order to show you it in practice, I will select here this command, which says, okay, peripheral number is LED green, so I will use the LED green, and the command is LED set on, so switch on the LED. And here, those two FFFF, this means for hardware profile ID. So we will use all the hardware profiles ID. Now, first of all, I will send Selective. So we should get that modules number 3 and 4, the green LED switched on, and we get data about the temperature. So if I send it out, you see that the green LED here and here, they are shining, okay, on the 3 and 4, and we also got the temperature. If I send just send, not selected, but send to all, we will have all of them green, like here we have them green, and we got a temperature from all of the modules. So this is the way how you can combine selective FRC with acknowledge broadcast. So basically the FRC and the command together, and also if you use the 2-byte data collection, then you would just get the 2 bytes from node number 1, 2 bytes from node number 2, and so on and so on. And again, you can combine everything. So this is to show you the automated bonding, and this was the acknowledge broadcast and selective FRC. If you don't mind, I will close this now, and I will go to our integrated development environment, which is, I guess, something which is more that you are more familiar with. I will connect my my CK. So now I have it connected. You can see it here. So basically now I can control my network. Let's say I want to switch off the green LEDs that are shining right now. So I will just go to LED, set let green off. So this gives me this command. I send it and I switch it off. Okay. So now we have it ready. The other thing, what I would like to show you is peer-to-peer communication. Okay. The peer-to-peer communication, for this I need a different hardware profile. So you see here that so far I used the DPA custom handler for auto network. So this is something which was uploaded in those modules. But now what I need there is a custom handler for peer lightning. Now the question is how I can get this new hardware profile into the modules that are already part of the network. Okay, so it's actually very easy. What I will do, I will take off this coordinator, and I will plug in the module with what is called CATS, so the programmer. The CATS, it's very powerful tool. Basically, you can use any module that you buy from us, and if you hit create CATS, you will create a special, let's say, programming or servicing tool. There are two types of how you can use it. One is RF programmer, and the second one is DPA service. The RF programmer, I will show you in a minute how I can upload the new handler. And the DPA service is used for, let's say, communication from the servicing tool to one of the modules. So if I know the vendor ID and the USEC, which is those are the security code that not everyone on the street can connect to your modules. So if you can set up the USEC and you can get the vendor ID from us, you can basically get connected from any kind of device or from any servicing tool to your device, which is already part of the network. So here I hit connect, and then what I need to do is reset the module on one of the, or reset one of the modules. So now I have wireless communication between my servicing tool and one of the modules. And what I can do here, I can first of all read everything about the module. So I can see what's the DPA version, the RF mode, you know, what's the TR module, what's the TR configuration, what are the available peripherals, what's the network information, what's the address, routing address, and so on. And here I can also use the wireless programming. I can unbomb the node, I can do the backup, I can do the restore, I can float the node as well, and I can also indicate the device. We can see that it flashes here. Yeah? Here it's flashing when I indicate it. So there are much more features also here. You can use it as a scanner. So basically you can see which devices were reset over the period of scanning. You have a list of all the MIDs and so on and so on. There is a video talking about the cats in detail, so you can watch it. Now, what I would like to do, as I said, I want to upload the custom DPA handler. I've done a small mistake because before I can upload the new DPA handler, what I need to do is to put those modules in what is called wireless programming mode. So what I need to do, I will put my coordinator back. See that the work with this is very easy. I will go to OS and I will send a command to run the wireless programming. If this is successful, you will see that all the modules will start flashing. So now they are shining green and flashing red. This means that they are in the wireless programming mode. So now they are waiting for a new program. So I will put my cats back. I will switch to the RF programmer. Here I will select DPA handler for Peer Lightning, and I will choose I want to upload the flash, and I will upload it. So now, actually, what we are doing, we are simultaneously uploading a new custom handler to all of the modules. So you see, all of the modules were successfully uploaded. So we have a different handler for Peer Lightning. So how the Peer Lightning works now is I will put my coordinator back so I can control them. So now the great thing is that I can control the network from my coordinator. So let's say I can switch on all the green LEDs, and I can switch them off as well. Okay, so from the central unit. But I have a program inside there that allows me also to control from one module to control the others. Actually, there are a few things that we need not to forget about. First of all, is that in the TR configuration, you can set up that the custom handler is enabled, and also that you enable the peer-to-peer. This means that the module listens also to the messages that are not only from his coordinator. And if I close this, then the program is written in the way that if I push the button on the module number 1, which is this one, I will switch on all of them. If I switch a button on any other, it will switch on the green LED on -1 and +1 module. So basically, if I push the button on the number 1, you see that all the green LEDs switch on for 5 seconds. If I push it on the module number 4, you see that it switched on module number 3, 4, and 5, which is not actually available. If I push on module number 3, it switched on module number 2, 3, and 4, and so on. Okay, so in this way, you can combine the communication from the coordinator with, let's say, local asynchronous communication. The only thing what you need to be aware of is that there could be a collision because you are using asynchronous communication. There could be a collision. So if you know that you are using, let's say, the communication from the coordinator, at the same time, the peer or the peer-to-peer communication shouldn't be used. So this is something that you need to take care about. So for example, in street lighting, where you want to use also like some detectors of like movement detectors, let's say the communication from the coordinator should be done during the day when you are not using the peer sensors. And when you are using the Pearson test, you should avoid the communication with the mesh network because there could be collision and you can get a like false results. So the last thing that I would like to show you is cloning. So basically, if this module, if the coordinator burns out, what I need is some kind of way that I can start controlling this network immediately without any, let's say, time delay. So basically, what I need to do, first of all, I need to do the backup of the coordinator. The backup of the coordinator could be done here in the IKF manager and do it here. Save networking data. So if you save the networking data, you have a backup file, and with this backup file then could be used for changing the MID. I have a special module that I will show it on. First of all, you need to to change the MID, you need to go to IKF website and actually purchase the change of the MID. So this is a feature which you will pay for. Definitely the IKF Alliance members will have much better conditions. We even think about they would have it for free. So basically, you would purchase, in brackets, you would purchase the MID file that will enable you to change the MID. Then you will go here to this wizard, and we have it already backed up, and we want to set MID. What we actually want is, first of all, I will close it, and I will show you that here now we have the module which is the MID is DE2. E2. Okay, so this is what you need to remember. We will do it from E2 to E3. So I will go back here to the wizard, and now please connect the module you want to set the MID to. So I have the module and I want to switch from E2 to E3. Okay, so current MID is E2, and now I need to select the MID that I want to go for. So basically, on the website, I ordered a change from E2 to E3. So this is the file that I got from the IKF website. I put it here. I put next, and now I need to find a backup file. The backup file is very important because without the backup file, you are not able to do the clone. This is for the security reason, because it's only the owner, the real owner of the module, can have a backup. Otherwise, anyone can do the backup from anything. So basically, you need to do the backup, and if you have the backup file, then you can change the MID to the original one. So now we choose the coordinator, the backup of E3, and we go next. If you would put here the wrong backup, it will tell you, hey, you don't have a right backup, so you need to find the right one. And now you just confirm, yes, I really want to change the MID. You do it, and in really a couple of seconds, you change the MID from E2 to E3, you close it, and you can double check that here, if I read it, it's E3. So this is the change of the MID. You can do it, or again, this will be released in summer. Then you can do it yourself very easily. The only thing, first you need to have a backup of your coordinator. You have to store this file. Then if something happens, you can do a clone very easily in a couple of seconds, as you saw it from any module that you get from us. So basically, this is everything what I had on my agenda for today. So now I will be happy to answer your questions.
Okay, we have a question. Is it possible to just extend a network and skip bounded modules in network to save boil time, or you can only build network from scratch?
No, actually, you cannot. The thing is that if you want to use the network, if you want to use routing, and then you need to have a network of bonded nodes, and you have to run the discovery. You can avoid, let's say, creating the network if you want to have a peer-to-peer communication, or if you have a star topology, then you can use this peer-to-peer communication that I showed you in the presentation.
Okay, so far we do not have any other questions. Oh yes, it's one more question. How I can use UART communication?
Okay, the UART communication, that's very easy. I will share my screen again. So the UART communication could be used as a peripheral. So one of the peripherals, now you should be able to see my screen. Here you can see the list of peripherals. So you have a coordinator node, operating system, you have the memories, you have the LEDs, you have the SPI, IO, temperature sensor, PWM, and here you have a UART. So basically, if you have a device that you want to connect to our module with the UART, then you would just use this peripheral. There is a command to open and close the UART, to read and write, and that's it. So basically, then you would just address, you would bond your nodes, you would do the discovery, and then you would say, okay, I want to read or write to the UART on the module number 5. You send it, and you get the data back. It's extremely easy. Even what you can do, we have a special hardware profiles for UART. So even with the coordinator, you can communicate through the UART or SPI. Those are the options.
Okay, so I don't see any further questions, so we can continue. Sorry, there is another one. Is it possible to use UART as a wireless bridge?
Yeah, it's a transparent communication. Yes. So basically, whatever you put into the data, it will be shown on the other side. So yes.
Okay. The next question is, how long can the data packet for UART?
The maximum packet is 56 bytes. 56 bytes using the DPA protocol. If you don't use the DPA protocol, so you would use the standard TR modules, then it's 64 bytes.
Okay. Next question is it possible to use 2 UART bridges in the same time?
It would be on the different channels. So this is not something which is better to discuss with my colleagues from support. So I would advise to write your question to the support@ikf.org, and then you can get like all the details about this. But basically, if you have one environment and you have different communications, that you can split the communication on more channels.
Okay. Next question: how fast is exchange data like a ping pong for UART?
Oh, I don't know this, but we are running on 19.2 kilobytes. So this is the speed that we are using. By the way, there was another question, like how is the power consumption of the module? So the power consumption, I said it on the beginning. So the TX, so during the transmitting the message, we are on 17 milliamps. And during the receiving, it's less than 13 milliamps, 13. And then we have like different low power modes, so you can get to basically hundreds of microamps. When it's sleeping, it's like 2 microamps.
Okay. Next question is it somehow noticed that buffer is in module is full, or is there any handshaking for UART communication?
So the buffer is full. Frankly speaking, I'm not specialist in these details. So if you really want to discuss the UART communication and like this UART bridge, I would recommend to go to our support. They will definitely give you much better answer than I can do. Sorry for that. Also, this handshaking and so on. Like we are using the handshaking and this kind of thing. If you have like direct communication, like the bridge, this is something you would have to program yourself. What we have for the DPA is basically the protocol for mesh networking. So you have 10 devices that are in the network. You can connect them from the UART, and you can send the messages, even like broadcast or one-to-one to the UART or read from the UART. But let's say creating a UART bridge that's I think not typical application of the IKF, but it could be used for it.
Okay. The other question: is the data encrypted, and if it is, what protocols like IES is used?
So the protocol itself, let's say, secure the data. It's not like fully encrypted, let's say. We want to integrate the encryption with the AES 128 during next year. But if you want, you can encrypt the data that you put into the, actually, before you send the packet, you can encrypt your data, put the data into the packet and then send it. So even the whole packet is, let's say, not encrypted, your data will be encrypted. So this is let's say the option. This is the option before the AES is integrated. But as I said, the protocol ensures that nobody else from the network can really read it.
Okay, thank you. Is it possible to use AT command to configuration modems?
Like, I don't know now what you mean as modems, because if you mean the modules are controlled with this DPA commands. If you have your own modem, let's say, or if you use any device, then you can communicate to your device as you wish, you know. And then let's say the software development kit, the SDK, the libraries written for Java and C, they have prepared the libraries to use this kind of commands that I showed. So there are, in Java, you have it ready to use the FRC, to use communication to the memories, and so on. But those are not, let's say, standard AT commands. Our DPA commands are something like AT commands.
Okay. So if we don't have any other questions, we can continue.
All right. So basically, this is all from me for now. So maybe we can wait for a few seconds for more questions. And if we don't have a question, like I would just like summarize and that would be it.
Okay.
All right.
So maybe I will remind when we give some couple minutes for more questions. Till then, I remind the special offer that we have for all the attendees of this webinar. During this week, you will receive by email the offer for special price for new modules and also for development kit with this module. So if you would like to, you can order it and send back this order to email you receive it from. And also all presentations can be found next week on SOS web pages. So if there is anything you would like to return to, you can find it at this presentation on our web.
Okay, so just from my side, thanks to all of you for attending this webinar. Thanks a lot for SOS for organizing this webinar. And if you have any further questions, please do not hesitate to contact SOS or the IKF directly. We will be happy to help you with your project, and good luck with your projects and business. And I'm looking forward to meet you on another webinar or even personally in our headquarters or at your place. So have a great day.
Okay, thank you very much, Simon, for your presentation. Also, thank you for your attendance. As Simon said, if you have any further questions, please contact us, and we will try to solve any of your problem you have with your project. And looking forward to our next webinars. We will continue in autumn after summer break. So thank you very much for your attention and your time, and have a nice day. Bye.
Thank you. Bye-bye.